Okay, rather than buying a motorcycle with his student loan check, Eric decided to invest his $6,500 into CDs. Remember, those are certificate of deposits. They're like savings accounts. The term of the CD is 30 months. He invests some of his money at a bank that pays 2.85% simple interest and the rest at a different bank that pays 2.2%. If he earned $421.69 at the end of 30 months, how much did he invest in each account? Okay, so we have to be careful with this one. It's not as straightforward as the previous questions in that we don't have just numbers to plug into a single formula and plug into the calculator. We have to apply some of our problem-solving skills that we picked up at the end of chapter 1. So the first thing to notice is that we don't know the principal amount for either account. So we have two accounts. We have the account, we'll call it account number 1, that pays 2.85%. And we have account number 2 that pays 2.2%. And all we know is that together, the two principals add up to $6,500. That could be $6,000 in one and $500 in the other. It could be $3,000 in one and $3,500 in the other. We don't know how that $6,500 is split up. So we basically have $6,500 and it's split between two accounts. So part of it is invested at 2.85% and part of it is invested at 2.2%. Okay, so we have two unknowns here. So let's express those two unknown principles symbolically. So we have amount, there's an N there, amount at 2.85% and amount at 2.2%. Okay, so we don't know what either of these are. So let's say the first one, amount at 2.85%, let's say that's P. P for principal, so there's P dollars there. So some of it is invested in the first account and the rest is invested at 2.2%. So how do we give a symbol to the rest? Well, we're starting with 6,500. Take away what's in the first account, and that's what's left for the second account. Okay, and this is important, and this is where we have to start with this problem. So the amount at 2.2% is whatever's left over from the 6,500 once you take away the P number of dollars that were invested in the first account. Okay, so then now we're starting to lay a foundation of understanding for this problem. Okay, so what we know is that the total interest earned, total interest is going to be equal to the interest from the first account plus the interest from the second account. So we have interest coming from two sources. Okay, so let's say interest from 2.85% account plus the interest that's coming from the 2.2% interest account. All right, so we know the total interest. That's 6,500. Okay, so now we need interest from the first account. Well, we have this formula for interest. Let me scroll up a little bit here. We're going to use the formula I for interest. Interest equals principal times rate times time. So that's the formula that we've used in the previous problems. Okay, so principal times rate times time. So in this case, in this problem, time T, is 30 months. But if we're using it in the formula, remember T always has to be measured in years. So we can't use 30 for T. We have to convert 30 months to years. So every 12 months is a year. 12, 24, that's 2 years with 6 left over, or 30 divided by 12. So T is equal to 2.5. Okay, so interest from the first account. Principal times rate times time. So we said the principal, so we're looking at the first account. The principal is P times the interest rate, which is 2.85%. So we'll convert that to a decimal. So divide by 100 or move the decimal point 2 places to the left. So that's 0.0285 times the time, which is 2.5. Okay, PRT, principal times rate times time, plus, so now we have the interest coming from the second account. Okay, so now we're here. So the amount, the starting amount is 6,500 minus P. So that's the leftover. That's whatever's left after some money is invested in the first account. So principal, 6,500 minus P, times the interest rate, which is 2.2%, or we'll divide by 100, so that's 0.022, times the amount of time, which is 2.5 years. Okay, so now we have an equation to solve for. Once we solve this equation and we get P equals something, well, that's this P up here. And once we have that, we're pretty much done. Okay, so first let's well, these are two numbers, so let's multiply those two numbers, and also these. That's two numbers. So let's multiply these numbers. Let's start to simplify. So we want to eventually sort of condense as much as we can and solve for P. Okay. Oh, sorry. Oh, that should not be 6,500. The total interest. Sorry, the interest. That's up here. That's the 421.69. So 421.69. Okay, that's better now that we've made that adjustment. So we've got 421.69 equals, well, now we need to calculate the product here. So let's bring over Desmos, and we need to calculate 0.0285 times 2.5. Okay, so that's 0.7125. Oh, there should be a 0 there. Let's put that 0 there. 0.285 times 2.5. Okay, 0.07125. 0.07125, and that's still multiplied by P. Okay, and then we've got the 6,500 minus P, and that's multiplied by, well, we need 0.022 times 2.5. And if we use the calculator for that, that would be 0.055. Okay, so one thing at a time. Now we have a product here, we have multiplication, so let's multiply. 0.055, we'll distribute that times the 6,500 and times the P. Okay, so that's 421.69 is equal to 0.07125 P plus, all right, so now we need 6,500 times 0.055. 6,500 times 0.055, and that's 357.5. And then we have the 0.055 times the minus p. So that'll be a minus 0.055p. All right, so we have two terms here, so we could combine them, just like we could say 2p plus 3p equals 5p. So we have the same thing going on here, just the numbers aren't as nice. But we can take this and combine these two. All right, so we have 0.07125 minus 0.055. .07125 minus 0.055. All right, so we're left with 0.01625. Let's go back to black. So we're at 421.69 is equal to 0.01625p. That's how many p's we have. And then there's a plus 357.5. It looks like we're moving in the right direction. Now there's just a single p here that we have to solve for. So we got to get rid of this 357.5. So we could subtract that because it's addition. And then we have to get rid of this 0.01625, and we could divide that because that's multiplication. All right, so let's subtract 357.5 from both sides of the equation. That way, these will cancel. And 421.69 minus 357.5, that should be 6419. And that's equal to 0.01625 times p. And one more step to go. So we can divide both sides. So this is multiplication. So we can divide 0.01625 from the right, and we could divide 0.01625 from the left. And that we need a calculator for. Okay, so we're down to 6419, 64.19, and we're dividing that by 0.01625. All right, 3,950, and we'll round to the nearest penny, so we'll keep two decimal places, so 0.15. So on the right-hand side, these two cancel, so we have P, and on the left we have our $3,950.15. Okay, let's put a box around this because that's the final answer for one of the accounts. So remember, if we go back to the top, this is the P we just found. So we just found the amount invested at 2.85%. So the rest, now we'll take 6,500 minus P. So this is at 2.85%. And now from this, we'll do $6,500 minus $3,950.15, and that's the rest. That's 6,500 minus P, and that will be $2,549.85. All right, and that is the amount invested. So let's put a box around that, and that is the amount invested at 2.2%. Definitely not a straightforward problem because it involves some algebra, involves definitely involves some problem-solving skills. Definitely want to think back to back in section 1.3, the problem-solving strategies that we took. George Poya's 4-step problem-solving process. So if we could zoom out so we could see everything, there's quite a bit of work here. And so this first stage in the problem, this was all sort of understanding the problem before we got into the actual calculations. We had to do some figuring here, sort of mapping out how we were going to approach the problem. And then once we had a clear understanding of what we had to do, then we start plugging in numbers. Okay, that does it for this one.